Okay, so my name is Christian Oricariet. I am Product Line Management Director at Finisar Corporation. And I'm going to discuss today the state of the art, if you will, in 40G and 100G optics in the data centers. So I represent Finisar. I work for Finisar. We are a corporation that, to those of you not familiar with the name, we are the leading vendor for optical transceivers and optical subsystems and components worldwide. We have more than 13,000 employees in multiple locations around the world, multiple, as you can see, research and development and manufacturing centers worldwide. We're also present in Brazil through our partner EPS, which is a sponsor for the conference. And we were founded more than 25 years ago in the US, in Silicon Valley. We're still headquartered in Silicon Valley. And we have a very large expertise in vertical integration, low-cost manufacturing, as well as innovation through this last more than 25 years. We have a significant market share worldwide. This is based on data from analysts. We have around 27% market share on optical transceivers, subcomponents, basically the market space that you can see highlighted. We're larger than the 2 or 3 second and third and fourth. So we're very proud and we're very thankful with our customers for that. So let's go into the topic at hand. Data center architectures, as you know, they're changing significantly. They are data centers are becoming larger, they're becoming more modular and more homogeneous. And this has to do with the way that they need to scale to support the large amount of traffic driven by many of the new applications and services. So things like YouTube, like Facebook, create an increase in east-west traffic. They create an increase in workload across many, or large number of servers, virtual machines, and so on, which really impact the way that data centers are architected. And whereas a traditional data center will be a 3-tier network, such as the one shown on the left, what we're seeing more and more with especially Web 2.0 and also increasingly across the market, the architectures are changing into a 2-tier leaf-spine network architecture. And that has, of course, implications in the amount of bandwidth requirements going to the server and going across the spine through the multiple racks of servers. So some of the changes that we're seeing are summarized in this simplified slide, if you will. The traffic between servers and between the different layers of switching are transitioning very rapidly, as you can see here. They're transitioning essentially from 1G, 10G per second, 40G, to 100G, and very soon to 400G per second. And I will provide some more details of what we think that evolution would be like, what optics are available today and in the future. So here the way that, again, summarizes the way that those connections are changing. Within the data center rack, which means to the top of rack switch to the servers, 10 gigabit Ethernet is being deployed right now. Either in single port or sometimes dual port, 10 gigabit Ethernet is the norm. The 25 gigabit Ethernet standard has started to be defined by the IEEE. And that means that next generation servers will use 25 gigabit Ethernet to connect to the top of rack switch. There is a big discussion now, and it will continue for a while, on what's the rate after 25 gigabit Ethernet. There are some that believe 40 gigabit Ethernet will fill that space. Some others believe that 50 gigabit Ethernet will succeed 25G in the next few years. So that's an open discussion. Between data center racks, basically between top of rack and spine switch, in some cases top of rack and core switch directly, we have 40 gigabit Ethernet being deployed right now, while 100 gigabit Ethernet is coming up very soon. Late 2015, early 2016 is when we believe per what our customers tell us, the 100 gigabit Ethernet deployments will begin in really large scale in that application. What follows afterwards is also a matter of discussion within the standardization community, within the industry. Some say that 400 gigabit Ethernet that's being defined for router connections will fill that next, will fill the space. Some others, and we tend to fall into that camp, believe that perhaps an interim rate of 200 gigabit Ethernet will make more sense. And that 200 gigabit Ethernet could be based on some of the same technology building blocks that will be used, for example, for 50 gigabit Ethernet to the server. So that's an open question. What follows after 100G between data center racks? The last portion is longer spans, which means either large data centers that have a significant distance between the core and the router, for example, or between buildings, either router to router, also router to WDM transmission system into the WAN. And that today is already deploying 100 gigabit Ethernet. That's what the majority of 100 gigabit Ethernet is being deployed for the last 2 or 3 years. 400 gigabit Ethernet is being standardized right now by the IEEE, and that will be primarily what will be used initially. And then, as always, there's discussion of what's next, what's after 400 gigabit Ethernet. And again, some people believe 1 terabit Ethernet is the right approach. Some people say it's not enough, so 1.6 terabit Ethernet could be. Some others are saying, well, let's go slower, use existing technology at the time, and let's use 800 gigabit Ethernet, which could be a multiple of 400 gigabit Ethernet. So that's, again, it's an open question, perhaps, that it's farther behind in discussions, but it will eventually happen. So let's start with showing the state today of 40 gig and then 100 gig. So what's the comparison of what's being deployed today? 40 gigabit Ethernet, of course, is much higher volume. You can see this in the charts from the light counting, which are market analysts for optical interfaces. So here we show multi-mode fiber. Blue is 40 gig, red is 100 gig. So the scale, and here's a single mode fiber. So as you can see, the scale of the comparison still is very large towards 40 gigabit. So we're going to have 40 gigabit Ethernet for a while, driven by current data centers, driven by the enterprise. But again, as you will see, 100 gigabit Ethernet also expects a big growth, especially in the leading part of the market, which again will be large data centers, will be Web 2.0 data centers with all these special needs that I mentioned. So 40 gigabit Ethernet today has the lowest cost per bit compared to 100 gigabit Ethernet. It does have a reach up to 300 meters on multi-mode, and that's very critical in most of the data centers. And it also can be used to break out to 4x10. So some of those 40 gigabit optics are really not point-to-point 40 gigabit Ethernet connections, but rather a fan-out application going to multiple 10G servers. So being used essentially as a 4 times 10 gigabit Ethernet module. So that also accounts for the large number of modules being used, that server application. 100 gigabit Ethernet modules already provide the highest density per bit in space. It provides also the lowest power consumption per bit, but a distance of only up to 100 meters on multi-mode fiber for now. And there are many of us in the industry that are already looking at ways to extend that reach from 100 to maybe 300. So stay tuned because that's, I think, going to change. 100 gig optics also support breakout. So essentially, it can break out to 4x25. And that's important because, as I said, next generation servers will be 25 gigabit Ethernet enabled. So these 100G modules can also be used from top of rack as a breakout, as you will see in a minute, to the servers. So what are optics today at 40G? This is a summary of what's out there for multiple vendors, for optical vendors. It's essentially QSFP plus form factor. It's a form factor that has 4 lanes by 10G electrically connection to the board. There's multi-mode and single-mode products. The multi-mode is the most prevalent, 40G based SR4, which can also be used as 4 by 10G based SR, up to 300 meters. Slightly longer on OM4, which is a higher grade of multi-mode fiber. For longer reach applications, 10 kilometers, 40 gigabit base LR4 is also available using duplex single-mode fiber, using CWDM type of optics. So that's also being deployed significantly today in data centers. And the third one is active optical cables. Multi-mode active optical cables for short point-to-point links that do not go through optical patch panels, but they provide a very cost-effective way of connecting, interconnecting two 40 gigabit ports. For those not familiar with active optical cable, I have a brief summary of what they are. An active optical cable is essentially two optical transceivers with a fixed cable, a fixed connection between them. So essentially, it's a connection that cannot be pulled out by the user. It essentially provides an end-to-end electrical connection going through optics instead of copper, and this has numerous advantages. For example, lower weight than a copper cable, tighter bend radius. So all the cable management, which is very critical in very high volume installations, is much easier with an optical cable than a copper cable. And this is what an active optical cable provides. Lower power consumption than copper, and so on. Compared to using transceivers, optical modules, instead of a cable, they provide a lower cost solution. These are not standards compliant because, again, they provide an end-to-end solution. So it allows us to provide a more lower cost products. They're also data center friendly. There is no dust issues which is sometimes a problem, given that there is no optical connector that's exposed. So as I mentioned, 40 gigabit optics, QSFP Plus can be used as point-to-point, 40 gig Ethernet, also 4x10 breakout, and of course a combination. And we see this in data centers around the world. Essentially, the combination of point-to-point, breakout, shuffle to multiple ports, etc. So they're very, the fact that they use parallel optics in the case of the multi-mode is a very flexible architecture for the optics. So let's move now to 100 gigabit Ethernet and the state of that protocol. It is, of course, already here. It has been deployed in many tens of thousands of ports already, specifically between routers or from the router to the WDM equipment, the transmission system to go into the WAN. So the vast majority of them are the bigger form factors, such as CFP or CFP2. I will show them in a minute to those that are not familiar with those form factors. So that's, again, 2-3 years of deployment. We have been at the forefront of that deployment, working with primarily router manufacturers. However, 100 gig is very rapidly expanding. The industry has been very busy working on new protocols to support data center needs for 100 gig. Things like 100G SR4, CWDM4, PSM4, which are all new standards and MSAs to support intermediate reaches and lower cost solutions that are required by data centers. There's also a variety of new form factors which are smaller in size and provide the higher port count or the port density required, again, by this new Ethernet switches that are being designed right now. Many of these modules I mentioned already will also be used as 4x25G connections from the top-of-rack switch to the servers, from 2016 forward. So we expect a significant growth curve, still not as much as 40G, but clearly for a portion of the market that requires high performance, the vendors will be there to support those needs. So one of the things that the industry as a whole has to deal with is proliferation of standards. And as the different needs continue to proliferate, and now with the Web 2.0 companies getting into the purchasing optics directly or getting more involved in the definition of optics, different needs require different solutions. So we're seeing a proliferation of standards, de facto standards and MSAs, which as an industry as a whole, either from the supplier or the user standpoint, is quite challenging. But again, the price is that you basically get specifically what you need or something that's closer to meet your needs. So we have seen this already at 10G, although not in such a big way. There's, of course, Ethernet standards at 10G, SONET standards, and some de facto standards, but not very many. At 40G, that has become much worse. There are many solutions out there which, again, provide breakout applications, also point-to-point with different fiber types and different types of optics to hit different performance points. So again, we will, as an industry, we will have to continue to support that. We're seeing something similar at 100G. It's only beginning, I believe. Hopefully, we can keep it under control because, again, the fewer the standards out there, the more the volumes increase per product, and that, of course, lowers the cost as well. So it's an interesting dilemma. You know, we have no solution or magic wand here, but it's something that is a challenge that we, as in the optical industry, suppliers and users have to deal with. Many times I get the question, why do you guys have so many varieties of optics, right? And it's not us guys, it's basically what the market is asking sometimes because of different needs, as I mentioned. So 100G optics at a glance. So what is the state of the art of what's being deployed today and in the last 2-3 years? Essentially, two main module types, 100G based SR10 for multi-mode applications, up to 100 meters, or with OM3 fiber, or 150 meters. And this has been in both the CFP and the CFP2 form factors, which are shown here on the left. And again, as I mentioned earlier, primarily in routers, some core switches, and also DWDM equipment, client-side DWDM equipment. Also, for those applications, but in single-mode fiber, duplex single-mode, LR4, 100G-based LR4 modules up to 10-kilometer reach are also deployed in significant numbers, again, in the carrier environment. CFP and CFP2 form factors, and to a lesser degree, active optical cables as well. There's a form factor called CXP, which has been deployed primarily as an active optical cable, mainly used in router interconnections. Has very little use in the front end, on the front panel space, primarily back in the chassis-to-chassis connection in very large routers. So you may have come across those. You know, some of the tier 1 router vendors use a CXP connection. So what has been the evolution of the form factors at 100G? I mentioned already CFP and CFP2 have been defined, designed, and being deployed right now for the last 2, 3, 4 years even. What has been, it's in the works right now to start deployment in the next few years are two new form factors which are much higher density, CFP4 and QSFP28 form factors. They address different needs. They're very similar in size, although they tend to address different needs and different market spaces. CFP4 is predominantly being planned or will be deployed again in the carrier environment due to some of the advantages that it has that I will not go into detail here. While QSFP28 is primarily the form factor of choice for the data center, for data center switches that are coming up with 100G ports. So this transceiver is almost identical to QSFP Plus being deployed today at 40G. It has improved performance to support up to 25G electrical lanes, so it has 4 of those. And again, will be deployed in either as a transceiver module shown here on the right, or as an active optical cable with fixed optics, with no optical connector. So again, that's what you can expect to see in the upcoming 100 gigabit Ethernet switches and with multiple ports. So as a comparison of all these form factors, here are the different port densities that they enable. So as you can see, I've taken as the baseline a real example of a 1 terabit per second blade, a 1 RU blade that has implemented 10 ports of CFP2, 10 by 100G, 1 terabit, and comparatively showing what densities are enabled by the different form factors. So CFP would allow less, of course. CFP4 enables up to 36 ports in dual belly-to-belly configurations. And QSFP28 enables a maximum of 40 ports. Again, in this case, stacked dual configuration. So very large bandwidth that's being enabled by this smaller form factors, again, which is what the data center market needs. You may start seeing lower port densities first. Again, it has to do with the density that the switch ICs will enable initially. But from the size standpoint, those modules are very compact. So summarizing, here is the state of the art, I would say today, of rather what's being deployed today. The state of what deployments are out there. As I mentioned, 10G and 40G primarily. And again, the products, of course, vary. The type of modules vary. We have cables, modules at 10G, and then 40G between racks, and then CFP, CFP2, long spans, and going outside data center. So that's today. So what we can expect to see in the upcoming, starting in 2016 going forward, it's something that looks similar, but now increasing in the rates. We're going to see 25G in the rack. We're going to see a lot of 100G between racks, both modules and cables. And also 100G, but higher densities between data centers or to the core switch, as well as 400G also popping its head very soon, hopefully around 2017 or so in the field. So in summary, we have a very large growth in web content and application. This is driving a lot of growth in bandwidth, and the way that data center changes in traffic impact optics is, we need smaller optics, many more quantity of optics, and low power. So the industry is really reacting to this, is providing into supporting smaller form factors, is supporting much lower power consumption and lower cost per bit for the upcoming years. So we're reacting to that need. And at the same time, we're investing in standardizing and working on components for 50G and above to support things like 400 gigabit Ethernet, which is being standardized along with 25G, and also thinking about 50G and 200G to be ready for the next wave of deployments. So anyway, that's my presentation. Any questions that I can answer now or in the cocktail? Hopefully you can join the cocktail. I will be there, and I can answer also questions there. So thank you very much. You can also contact us through the Finisar website, and I can answer any questions in that way. Yes? There's no...
Som, por favor, ali para a pergunta.
Your great presentation, but you talked most about the data centers connections. What can we expect from Finisar for metro and long-haul interfaces? Actually talking about 100 gig or coherent interfaces or something like that. Do Finisar have this on pipeline or roadmaps?
We are working on coherent products. Of course, I cannot give you a lot of detail in this public forum, but we can certainly privately talk about it. We are developing 100G pluggable modules for the long-haul application, things like coherent with analog interfaces to DSPs on the host and so on. So that's certainly going pluggable as well and decreasing in size rapidly, maybe a little bit slower than the client. There are other challenges, especially in power dissipation there. Sure. But we're certainly focusing on pluggable as well for the line.
Okay.
Yeah.
Thank you.
So we can follow up later on with more details privately.
Okay, thank you.
Mm-hmm.
Mais alguma pergunta? Por favor, uma pergunta lá.
Actually, it's more an abstract question. He asked about the metro, and my curiosity would be, with fiber to the home, taking to people's house, usually you get the fiber and then you convert to copper. We know there is technology that you can plug a fiber directly to the computer or to the router, but how do you see happening in the future? Any kind of connection directly to, so the people at home would get fiber directly instead of, you know, going from fiber to copper and then to wireless, whatever.
Mm-hmm. I'm not an expert on that access piece, but certainly there are people working on directly an optical connection. In fact, there are some deployments, I believe, in the Japanese market in particular, with a native optical interface for the home using optical connections directly. It's an area, unfortunately, that I don't know very well, that access point. But we can certainly get you in touch with the experts at Finisar working in that space. Mm-hmm.
Mais alguma questão? Lembrando que as questões podem ser feitas também em português.
Pode perguntar em português, né? Sim.
Então, gostaríamos de agradecer aqui ao Christian pela palestra. Muito obrigado.
Thank you very much. Thank you.